folks, now it's time for the Poisson distribution. I hope I'm pronouncing that right. It's French. Poisson. The Poisson distribution is another one that's only for a specific case. And so it's used to, I'm going to just read this out loud, it's used to estimate the number of random occurrences in an event. And it's actually, you know what, reading it was pointless. Okay, I'm just going to give you an example. So say it is known that 10 customers visit a bank every 5 minutes. Okay? So for example, like say it's 10 a.m., right? And then at 10:05 a.m., on average, 10 customers will go through there, okay? Sometimes it'll be 8, sometimes it'll be 9, sometimes it'll be 12, sometimes it'll be 13. But on average, if you do this enough times, about 10 customers will come through a bank every 5 minutes, okay? But what if, and what do they call this probability? They call this lambda. So this is lambda, okay? And what if I want to know the probability that 8 customers will go in the bank, will visit the bank in 5 minutes. Okay, so I know that on average 10 customers will go in there, right? That's the expected value, that's lambda. But what's the probability that 8 customers will go through? So I think I have this wrong. Oh yeah, okay, sorry. No, I have this right. This is x, okay? So x is 8. So the probability of x is equal to e to the minus lambda, lambda to the x power, all over x factorial, okay? The mean, obviously, is lambda, right? The mean is going to be 10. You already knew that. And the standard deviation is the square root of lambda, okay? So the example that they give, so I'm just going to go ahead and do an example to make sure I drive this home, because I think this was a terrible explanation of it, to be honest. All right, so in a binary data stream, it is known that there is an average of 3 errors per minute, okay? So the average number of errors in a data stream, okay, is 3, okay? So that means lambda is equal to 3, okay? The average number, and I put a line here, right? These are the formulas, right? Okay? And this is like the theory, this is just a random example. This is a new example, so this is new example, okay? So the average number of errors in a data stream is 3, so that means lambda is 3, right? I want to know the probability that no errors occurs. And how many minutes? Oh, per minute. This is 3 per minute. Okay? Now here's the thing with the Poisson distribution. You can only get the probability in the exact same time interval that you had before. So here, if I want to know the probability that 8 customers come in 5 minutes, that's fine. But if I want to know the probability that 8 customers visit in 10 minutes, that's a completely different computation. Okay? So in this case, I have the average number of errors in a data stream is 3 per minute, and I want to know the probability that there are 0 errors per minute. What's that probability? Well, if you look at the formula, it's e to the minus lambda. I don't even need to write it again. So it's e to the minus lambda is 3, right? Lambda is 3, x is 0, and then x is 0, so 0 factorial. So 3 to the 0 is 1. E to the negative 3 is 1 over e to the 3. 0 factorial, if you look at like it's like Bessel functions or something like that. 0 factorial is 1, and so you get 1 over e to the 3, which is, according to this, 0.05, okay? If you didn't have a calculator, it'd be what, 2.7 times 2.7 times 2.7, which is almost like 9 So I would say it's like, or sorry, 3 times 3 times 3 is like almost like 27, but a little less than that. So I'd call it 25. So 1 divided by 25, I would say approximate, right? And I think that's 1 over 20, if I had to guess. Yeah, maybe 1 over 200. Maybe I did this wrong. It's hard to say. Anyway, I don't have a calculator. I'm just issuing it. Anyway, so hopefully that's hopefully that helps out. That's the Poisson distribution, and I'll post some homework on this and post in the comments if you have any questions.